Hey everybody, Mr. Tannen here. Here to make a video from the summer work. This is number 10 from the zeros of quadratic functions. This was one that there are a lot of questions about zeros of quadratic functions. And really, anytime you find the zero of any function, what it's asking is a zero is where does this function have an output that is zero. For what x value would my output be zero? So we could think of it, if we were to graph it, that would be where this graph would hit the x-axis. Those are called the zeros. There's another way we could do this algebraically by saying, well, my output is f of x, so replace that with zero. Then could I systematically solve to find the values of x that would satisfy this equation? And some of you may be already thinking, well, Mr. Tannen, this is actually something called vertex form. And vertex form tells me that this is going to be shifted 7 units to the right, 1, 2, 3, 4, 5, 6, 7, and then 9 units up, 7, 8. I think I counted correctly. So this would be a parabola with its vertex at 7, 9, and it's got a positive, no change in the leading coefficient, so it'll look something like this. Be a parabola like this. So Mr. Tannen, this one's got no zeros. Well, let me tell you something. You're right with the graph, it's got no zeros, but there's actually there's a way we could express a solution to this using imaginary values, which tells us a bit more about the function, even if it doesn't necessarily have zeros that we could express on the graph. So let's go about this algebraically then. So I've got this. Well, I want to get my x by itself. Let me subtract 9 from both sides. Okay, bam, bam. Negative 9 equals x, the quantity x minus 7 squared. Right away, well, I need to get closer to the x so I could square root both sides. So I would get the square root of negative 9 equals, well, now that's just going to be x minus 7. And don't forget, when I take that square root, I have to say, well, it could be positive or negative, the square root of negative 9. But right away, some of you might be saying, Mr. Tannen, you can't take the square root of negative 9. Well, let me explain something here to you, which maybe you have learned, maybe you haven't. Sorry if it seemed unfair to have it included in the summer work. But there's a way I could actually express this using what we call imaginary numbers. So what I could do is actually break the negative apart, and I could now separate this. And we know the negative is what's causing me to not be able to take the square root. So what mathematicians did is they called the square root of negative 1 the imaginary unit. So we could actually replace the square root of negative negative 1 anytime we encounter it with this imaginary unit I. So if I keep now that I've got that, well, I can know the square root of 9 is 3. And now we're saying that the square root of negative 1 could be replaced with I. Now all I have to do is add my 7 to both sides. And I'm actually going to now put my x here. So even though this is not a real zero, as we said, it's an imaginary zero, this would have two imaginary zeros at 7 plus or minus the square root of 3i. So if I went up here, I think that we could check the answer key. And indeed, we got the correct answer. And we're going to be talking more about imaginary numbers. I'm so sorry if that was frustrating for people that this came up in the review if you hadn't learned it in the past. But I'll make sure that we take our time for everybody who would like to really learn more about the sort of conceptual background and the reason we have imaginary numbers. What it does allow in this case allows us to express an answer in a situation where otherwise we would think we would just say, well, there are no zeros. But this gives us a bit more information about the function, even though we know it wouldn't show up on the graph. Hope this was helpful. Thanks everybody. Hope you enjoyed the video, and I'll see you very, very soon in class. Yes.